So it comes down to the question that where does S3 fit in the entire data engineering pipeline? So as far as AWS is concerned, S3 is very, very important for data engineering and machine learning services. Because as I told you that S3 is a distributed storage service along with a lot of other features. So that's why S3 plays a very, very crucial role in setting up the entire data engineering pipeline for AWS's data engineering pipeline. Now, just to recap what a data engineering pipeline is. So what we do is that we get data from various data sources, and that is the generate phase. And after the data is generated, we ingest and collect the data and then we store it, right? So data generation and then ingestion and collection, and after ingestion and collection there is data storage. So this is the first place where storage is getting used. Then we do processing and transformation on that data, and even after processing and transformation we store the data somewhere. So there's another storage layer coming in, and finally we do analyze and consume. So these are the high level stages of data engineering pipeline. If I look at diagrammatically, we have this generate stage wherein the data is generated from either data sources like OLTP data stores. It can be relational or NoSQL databases like RDS, Aurora, DynamoDB, DocumentDB, MongoDB, etc. We also get data from streaming applications or even normal applications, because a lot of normal applications or mobile applications generate a lot of data. And if you have OLTP data stores, we can use CDC tools or change data capture tools like AWS DMS, which is Database Migration Service, or open source Debezium. And these can be used to capture the data and store it in some place. And similarly, for streaming applications, we can ingest and collect using either Kafka or AWS Kinesis, etc. And after collecting or ingesting the data, then also we store the data somewhere. So this second stage is the ingest stage, wherein we are ingesting data from relational or NoSQL operational databases or from streaming applications. And then we store the data somewhere, and that storage is basically we are storing raw data. This is not processed data. So typically this is where S3 is used, and S3 is used as a data lake here because we are storing raw data, and the data can be in any form. It can be CSV, Parquet, it can be JSON, etc. Right, so that's where S3 plays a very important role in the raw data capture. So we store raw data in S3 data lake. We also use databases like HBase and Redshift. Now in Redshift we have something called streaming ingestion using materialized view, which you will see in the Redshift course or the Redshift chapter. We have open source NoSQL databases like HBase, which can be created on top of EMR, or you can have your own self-managed HBase also. There can be other data stores also like DynamoDB, MongoDB, etc. But in most of the cases, we use data lake storage to store the raw data. And S3 is the suo moto for data lake storage in AWS. And after that, once the data is stored in its raw format, the processing happens. So processing and transformation happens, and various tools like Spark, Glue, Flink, etc. are used here. We use stored procedures in Redshift, or we can do the processing in Redshift itself using something called ELT, or extract transform load. You can use AWS Lambda also, which is serverless compute, and Lambda can be used to transform the data and maybe store it in somewhere. Similarly, we can use EMR also, because apart from Spark and Flink, EMR gives a lot of other tools to do the processing and transformation. Now, one more thing here is that we can have a line from ingestion to the processing directly, because let's say we're getting streaming data in Kafka or Kinesis, then you can use Spark streaming or Flink to do processing on top of it, which is called stream processing, and then store the data somewhere. Now, if you have to know about stream processing, Spark streaming, Flink, etc., you can enroll for my second video, which is Data Engineering Volume 2. Anyway, so the processing layer can be glued to the ingestion layer directly also. And then after the processing or transformation is done, we again store the data somewhere in its aggregated form or in its transformed form or the way we want to store the data in a way so that it is accessible to the reporting layer or the consumption layer or the analyze layer, analytics layer. And this is the processed data layer. Here we store the data after everything is processed, and here also S3 data lake plays a very important role. So you can store raw data also in S3, and we can store processed data also in S3. So processed data can be stored in either Parquet format or ORC format mostly, because as the data is going to be used in analytics and reporting systems, so those are the downstream applications for these processed data. So typically we store the data or we store the processed data in Parquet, ORC or any other columnar format. But in raw data in this particular stage, we can have data either in JSON, Avro, CSV, Parquet or any other format that you can think of. But typically in processed layer or in this particular stage, we mostly store the data in Parquet, Avro or ORC format, mostly in columnar format. And there are other data stores also which can be used. For example, DynamoDB can be used. Let's say you are running OLTP queries or OLTP dashboards, then DynamoDB can be used, or you can use RDS also, like Relational Database Services, RDS and Aurora, wherein we want to generate reports on a very small amount of data, not on historical data. So if we want historical data, you can use Redshift. We can store the data in Redshift, and eventually we'll have to archive the data from Redshift to S3 also. Any of these storages can be used, and S3 also plays a very important role in the processed data layer. And after that, we have this analyze or consumption layer where Athena plays a very important role, and Athena reads data from S3. Athena can also read data from RDS, DynamoDB, Redshift using other data sources, but Athena was meant to give you ad hoc analytics platform in a serverless fashion on the data that is stored in S3. So you can get more details about Athena in the Athena chapter. So now here, as I said, we can store data in S3 and then use Athena to query it. We can use tools like Power BI and Tableau, which can connect to either Redshift, which is a data warehousing system, or it can connect to Athena also. So reporting tools like Power BI, Tableau, MicroStrategy, Qlik, etc., they have or they can connect to Athena using JDBC and ODBC drivers to generate reports. But Athena actually runs query on top of S3, so S3 plays a very important role here as well. And then it also starts the beginning of another pipeline, which is called machine learning pipeline. The processed data is basically sent to the machine learning pipeline, wherein the pre-processing of the data is done for machine learning. So if you want to know more about machine learning, I'll be coming up with a course on machine learning basics. You can enroll for it also. As you can see, S3 plays a very important role here for another pipeline. So the data can be received from the process data layer and sent to the machine learning pipeline. But in data engineering, we can store the process data in S3, and we can have various downstream consumption layer applications which would be reading data from S3. So this is where S3 fits in. Now a few more things is that which is not presented in this particular diagram is that we can load data from S3 to Redshift directly using copy command. We can load data from S3 to Aurora, MySQL and PostgreSQL tables also. We can load data from S3 to DynamoDB tables also. And if you are running Spark code, which typically runs on HDFS distributed storage, instead of HDFS, we can use S3 also. So when we run Spark and Glue, we can mention S3 as a source because S3 works as a distributed storage also. So you can use S3 in Spark and Glue instead of HDFS. So this is basically where S3 can be used as an input. But S3 can be used as an output also. Like for Redshift and Athena, we have something called unload commands, and those commands can be used to export data from Redshift and Athena tables and store it in S3. So basically, if it is Redshift, then you export the table from Redshift tables to S3. If it is Athena, you read the records from S3 using Athena, do some transformation using Athena SQL, and then store it back to S3. We can export tables from Aurora, MySQL, and PostgreSQL databases also. And we can export tables from DynamoDB also to S3 directly for further processing. So as you can see, S3 plays a very important role in the entire AWS data engineering pipeline. So if you have your data strategy on AWS, you cannot skip S3. S3 becomes paramount in that strategic technical decision. So various use cases of S3, I'm just giving a high level overview, and at the end of this particular chapter I'll show you various architecture using S3, but at a high level what are the use cases. As you might have already guessed that S3 can be used as data lake to store raw data and processed data. Why? Because S3 can let us do that. We can store any type of file format in S3. So that's why it is very good for our data lake. We can also use S3 for Lakehouse. So in the introduction, I told you about Lakehouse. So what is Lakehouse? It is basically a combination of data lake and data warehouse. So what it entails is data warehouse like features on top of data lake. But for that, we need some enabler technologies, and those technologies or frameworks or platforms are called Iceberg, Hudi, and Delta Lake. And we can create Iceberg, Hudi, and Delta Lake tables on top of S3 also. So S3 can be used as a lakehouse as well. In fact, when we talk about Athena Iceberg tables, we'll see that I'll be using S3 there. I'll be storing the Iceberg tables in S3 itself. Not only that, you can use Spark to write data in Iceberg or Hudi or data lake tables, and those tables would be stored in S3. So the moment you use these table formats or these open table formats on data lake, it becomes a lakehouse. And S3 can be used as a lakehouse also, because you can store raw data or raw files like Parquet or processed data, in fact, Parquet, Avro, CSV, etc. And then you can use Iceberg, Hudi, Delta Lake on top of it. And as I already mentioned, we can use S3 as a distributed storage, just like HDFS. So what is HDFS? HDFS is Hadoop Distributed File System. And it works like the architecture that I was showing you in the first slide, that is distributed storage, wherein you break a very large file into small pieces and store them in different servers. So those servers where the data are stored, those are called data nodes, and there's a metadata server which is called name node. So S3 can be used as HDFS also, but there's a lot more than HDFS. It is not a replacement of HDFS. So you can think of HDFS as a subset of S3, or S3 is the superset of HDFS. We can use S3 for data archival from various OLTP and OLAP databases. Like we have tables and databases, let's say on RDS, MySQL, Postgres, Oracle, SQL Server, etc. We can export data from those tables and store it in S3 and remove the data or delete the data from the OLTP store. So S3 works as a data archival place, a data archival storage. As you can archive the data in S3 pretty easily, you can keep your OLTP storage within limit so that your performance is not impacted. Now, not only that, S3 can be used as a data archival solution for data warehousing technologies also, like Redshift. So as I already told you that we can use a command called unload to unload or extract records from a table and store it in S3. So what happens is that, let's say you want to store 3 years of data in S3, and for another 5 years, for some reason, compliance reason or maybe bank statements, etc., you can archive the data in S3 and then use Athena on top of it to query those archival data. We can export data from NoSQL databases like DynamoDB also. So DynamoDB is also an OLTP store. We should make sure that the data are archived from OLTP store. So we can use table export in DynamoDB to export the data from DynamoDB tables to S3. And in doing so, we can use S3 as a archival solution for NoSQL databases also. We can use S3 as backup storage. In fact, a lot of the AWS services use S3 to store backup data. For example, whenever we take backup of EBS, that is stored in S3. The backup of RDS and Aurora are also stored in S3. So Redshift takes continuous backup on S3. DynamoDB also takes continuous backup on S3. It is used as log storage also. So S3 can be used as backup storage as well. Let's say you have two databases like DB2, MySQL, Postgres, Oracle, etc. All these databases provide some backup solutions. So you can export records in either binary format or CSV format or any other format, and you can store that entire file in S3, and later on you can use that file to restore the data using that backup. We can store application log files in S3 also, so that we get or keep the historical information of what has happened in the application, what record has the application logged, etc. We can store S3 for media content as well. Just to give you an idea, Netflix actually uses S3 to store its video files and image files, etc. So when you go to Amazon.com or Amazon Prime, they also use S3 as their media content and static content also. For example, Amazon.com, you see the pictures of the products, those are actually coming from S3. So whatever online streaming platform you can think of, all of them use some object store or the other. For example, YouTube uses Google Cloud Storage or GCS, which is exactly similar to that of S3. So it can be used to store media contents as well. There are various use cases, but we'll be focusing on these four: data lake, lakehouse, distributed storage, and data archival, because these are the use cases of S3 for data engineering solutions. So we'll not be talking about application log files or media content because those are completely separate. I want to talk about S3 only in the purview of data engineering. So that's why I'll cover S3 as a data lake, as a lake house, as a distributed storage, and data archival. Now finally, before concluding this particular section, I want to tell you about the difference between object store and block store. You have already seen what an object store is and why S3 is called object store, because we store not only the object, we store its metadata, its storage, key, etc. So that's why it is called an object, because a lot of information are stored together. Not only the data, a lot of other things along with data. So that's why collectively all of them are called an object. So what is a block store? Wherein data is stored in blocks. So for example, EBS or Elastic Block Store. So if you want to know more about EBS, you can go through the video in appendix, which is EC2 and EBS. So what happens in block store? Data is read and written in blocks, and the size of the blocks are defined by the operating system or by the device. But typically what happens is that, let's say we have this disk and we have application. Now this application can be anything. It can be a Java application, Python application, database application, etc. So what they do is that when they write in blocks. So it's not record by record. So single block can contain multiple records. So let's say single block size is 4 KB, then and a single record is, let's say, 1 KB, then a single block would contain 4 records. And first it is written in RAM and then it is stored in disk as a single block. Now again, if the database or the application is keep on writing, then it will be written to the second block, third block, so on and so forth. While reading also, when you want to, let's say, read a single record, we'll be reading the entire block. Again, taking the same example wherein a single record size is 1 KB, and let's say I want to read a single record of a customer, and we know that there are 4 records in a particular block. It does not matter that even if you want to read a single record, the entire block would be read and given to the application. Of course, if the record size is more than 4 KB, then multiple blocks would be needed to store a single record. So this is how data is read and the data are written in blocks. So that's why it is called a block store. Now let's say I'm to read a separate record, it will read a separate block and then send it to the application. Now the question is, can we create object store using block store? The answer is obviously yes, we can do that. So in the S3 architecture, I had shown you some disks underneath, right? So we have various nodes, we have thousands of nodes or hundreds of thousands of nodes, but all the data are persisted in some storage form or the other. And S3 also use block store only behind the scenes. So that's why we can create a block store or an object store on top of block store also. But the problem is that the manageability, the scalability, the availability, handling all these are very, very complex. It's not straightforward. Imagine wherein you have hundreds of thousands or millions of disks. How do you handle it? How do you scale? How do you scale up and scale down? How do you make sure that your data is available all the time? Because of these problems, we use S3. So we have multiple nodes and then there are multiple services on top of it. And S3 gives us the API, and we go ahead and use S3 as a distributed storage or as an object store. We do not use block store in S3. We do not use S3 as a block store. We use S3 as a object store because we send request to S3 API, and S3 API helps us to read the records and write the files. Again, we do not read block by block. We read the entire file and also write an entire file. We cannot use block by block reads or block level writes in S3. That's why we cannot use S3 for application storage and database storage. Meaning, let's say you have a MySQL database created on top of EC2 instance. You cannot create or you cannot use S3 as a MySQL database store because MySQL as a database engine writes in blocks and reads in blocks, but S3 does not give us that capability. We have to write the entire file or read the entire file. So that's why we have to use plain block store in those cases, for example, EBS. Same is true for any applications also. But we can use S3 as a distributed storage. So instead of using HDFS, we can use S3. A point to note is that HDFS can also be thought of object store because HDFS stores data, metadata, and a little bit of object key also. We can actually use S3 as a replacement of HDFS. But S3 gives a lot more other services along with it. That's all about the introduction of S3. Now let us go into a little bit more details and understand the basics and various features that are provided by S3.